The modern keyboard is optimized for two hands. Inability to use one or both arms drastically limits our ability to type and compose text, which is a critical task for many individuals and lifestyles. I'm Ryan, this is Kristen, and today we'll be discussing how we can improve composition ability for people with short-term arm injuries. First, let's start with an area that's been researched more heavily and there's more products for. So first, we're going to look at background of solutions for those with more severe, more long-term impairments. For those with extremely limited use of both hands, eye tracking software is a very effective method for communication and also text composition. There's prediction-based typing, which uses algorithms that can drastically reduce the amount of buttons necessary to compose text to as little as 3 or 4. There's also a number of one-handed keyboard designs which take the standard QWERTY keyboard that everyone is familiar with, seen above, and converts it to a smaller one-handed keyboard. These one-handed keyboards require multiple strokes, meaning multiple keystrokes to indicate a certain character. Lastly, there's dictation software. Dictation software has a wide array of uses, including iPhones and cars. But there are many issues with using it, which we will get into in more depth. What we're most interested in, however, is not severe and long-term injuries, but more short-term injuries. So first, let's start by defining that. Short-term injuries is one with a relatively short time span, usually less than 6 months. In this case, individuals are often in a sling or a cast and have use of their hand, but not greater arm motion. When speaking with an interviewee who was in a sling for multiple months, he expressed that it was very difficult to complete his work and he would often have to stay late because it was very difficult to type with one hand, and this was very frustrating to him. He ultimately used dictation software, which was an improvement, but a big issue was that this causes lots of errors that he had to go back and fix. Regardless, it was still not as effective as the two-handed keyboard that he was used to. There are a number of other areas that have been explored, including multiple stroke typing, gesture-based typing, and chorded typing. And these are very interesting. However, the big issue is that these are generally difficult to learn. What we want to place a huge importance on is intuitive typing and ease of learning. For someone with a temporary injury that may only last 2 months, it is less likely that they'll want to put in the time and effort to learn a new way of typing than they've been doing their entire life. So what we've seen so far is that there's no current good solution for those with temporary injuries that only allow them to have one arm for typing. We think this is a problem and a valuable area that has surprisingly not been explored very heavily. This leads to our hypothesis.
So our hypothesis looks to expand on dictation software's current ability by combining it with external handheld device to see if we can improve the efficiency and satisfaction of users while they're composing. Specifically, we're looking at people with temporary impairments who are used to using the two-handed standard QWERTY keyboard. So this is the device we've proposed to test our hypothesis. We call it the nunchuck indicator. It's modeled after the Nintendo nunchuck, and you can hold it in your hand and even in an arm that's constrained by a sling, and you're able to press the buttons with the finger digits specified on the image.
To get into a few more details on this design, there are 5 tactile switches similar to what you would find in a mechanical keyboard, and a 2-axis joystick, so up, down, left, right. These sensor values are sent to an Arduino for our prototype, and then the commands are sent to a PC via a custom driver, which we will design. The nunchuck has 4 different states with various functions. The big ones are composing and editing, and then you also have the ability to scroll along the body of text and to spell out certain words that may not be recognized by dictation software. First, let's start with composing. So for this, we wanted to think of the main functions that are very important for composing text that you would otherwise in dictation software have to verbally say. So the 5 buttons in this case, the first being switch. So switch allows you to switch in between composing and editing state, which we will get to later. And the 4 functions in this state are insert period, insert comma, insert new line, and insert question mark. So the idea is instead of having to use dictation software to say insert period verbally, you just press a button, which is a lot quicker and more natural. For our editing state, we have 5 buttons again. Switch also switches back to composing. And then our 4 functions are delete character, insert flag. What a flag is basically if you notice that there's an error while you're dictating, you can flag that as a reminder to go back and fix it later. The 3rd button is insert tab. And then the 4th one you can hold down to spell out a word, as we discussed earlier. These functions we think are ones that will be very useful for both editing and composing text. But part of this project is also to figure out which ones are more useful than others, and are there any other functions that we may want to add in the future. Lastly, the joystick gives us the ability to scroll along a body of text. An example of when this would be useful is if you want to go back a few words to insert a comma or delete a word or any other function. This allows you to do it with your hand holding the nunchuck as opposed to having to scroll on a touchpad or with a mouse. So now we've described our product. Now we're going to get into how we want to test it and what we're going to compare it against.
So to test our hypothesis and this nunchuck device, we will recruit 20 people who heavily rely on typing to perform their jobs. These will be people who are used to using a standard QWERTY keyboard with 2 hands. Participants in the study will not have to have a current or previous arm injury. We will simulate this injury by placing their arm of their non-dominant hand in a sling as pictured. This experiment will be broken up into two phases. So in phase 1, with their non-dominant hand constrained in a sling, participants will be given access to dictation software, a standard QWERTY keyboard, and a mouse, but they will be instructed to use the dictation software as their primary means of composing. The participants will not have used dictation software in the past, so they'll be given 30 minutes to freely practice with the setup. Once they're done practicing, they will be asked to compose a scripted email of 250 words, including formatting and punctuation. And once they've completed this task, they'll go back and make 5 predetermined edits to complete phase 1. And in phase 2 of the study, subjects will have the same setup and instructions as phase 1, but this time they will also be given our device, the nunchuck indicator, to hold in their non-dominant hand, which is constrained in the sling. After subjects have read the documentation on how to use the nunchuck and completed practice exercises, they will follow the same procedure as they did in phase 1, which will allow us to draw comparisons between the 2 setups. So some of the data we will collect and then compare between the paired phases of the study include such metrics as frequency of button presses, comparing keyboard and nunchuck usage, comparing typing speed and error rate, and just overall user satisfaction and preference. Comparing these methods and data will allow us to report metrics that are not previously reported in literature.
This data is very useful to us because it allows us to inform how people are using dictation software. What we want to know is, what are the common errors people are making? What are the buttons on the keyboard that people will press? What are the buttons on our nunchuck device that people will press while using this? This is an area of research that is surprisingly sparse, and getting more information on this will allow us to much better inform the design of our design for an assistive typing device. With this data, we can improve upon our current nunchuck device. And as I previously alluded to, possibly change the different functions that we have, as well as the layout of the buttons. Overall, what we want to do is answer this simple question. Does enabling the use of the hand on the injured arm increase efficiency and our ability to compose text well? Ultimately, what we want to do is to be able to approach two-handed typing ability for people with injuries that don't allow them to use 2 hands. And we think that is a very applicable goal for many people who rely on typing and composing emails or similar things in their daily life.